Okay, so let's go ahead and take a look at this objective. So this objective is our first unit or our first section in proving. So just doing some basic proofs. And I would say I would want 90% or 90 and even 95% of your proofs to be a 2-column proof. We do a flowchart proof. We do a paragraph proof. And part of the reason why we do that is because future testing that you guys will do will require you to know the difference between the three. So really, when you look at writing a proof, first thing I probably would do if I don't have one is I would try to draw myself a picture just so that I could visualize what's actually going on. So that was my step one. And then there's a lot of math terms, right? Deductive argument, those types of things. But really what I want to do is I want to take myself step by step through okay, well, what would I do next to solve my problem? Or how could I go about doing this? So I think it's probably easier. One of the theorems that we do need is a midpoint theorem. And then we'll get other theorems as we kind of progress through. But you do need to remember the stuff that we've done before. So there's the segment addition postulate, angle addition postulate. And so you will need those. And then we'll add also to it. So here, my first example is that I don't have a picture. So I'm going to try to draw one. And I'm very bad sometimes at drawing when I don't have a ruler. Let's see. So it says P to R, and then Q is the midpoint. So here's Q. I want to prove that P to Q is congruent to Q to R. Well, before I prove, first thing about midpoint is that I create two equal segments. So what I would want to say is that P to Q is equal to Q to R. And this would be definition of a midpoint. And I'm okay with you guys doing a little bit of abbreviation because we're just starting to learn this stuff. But the one thing I will caution you guys about abbreviating is the fact that I have to be able to read it, right? So don't abbreviate where I'm I have no idea what you're writing. Also, there's a difference between equality and congruency. So this symbol here is congruent. Whenever you have the congruent symbol, you do need the little segments or lines over it so that I know, there's a difference. When we talk about equality, we're talking about measurement, actual values. And so that's where we don't have to put the little line segment tool over it. And we'll start to talk a little bit too because order matters, how you write things. But when we're first initially trying to start this process, I'm not going to be super picky. I'll start to correct you, and then over time, as we progress through the unit, you'll fine-tune your proving skills. Okay, so after we go from equality to congruency, well, then that's definition. Oh, man. Of congruency. Okay, so that's how I fill this out. And then there's there's different ways of proving. There's sometimes where I ask you to generate it all by yourself, and so then there's multiple ways I guess you can get to the same answer. Here I try to do a lot of what I call Swiss cheese proof, fill in the holes, fill in the blanks to get where you need to go. Okay, so here I want to prove that x is equal to 2. So first thing is that P is the midpoint of J to K, and that's given. So if that's a midpoint, then that means that J to P and P to K are congruent. And this is a flowchart proof. It looks like an R. This is a flowchart proof. And so we write the statements inside the boxes, and then we write why it's the case outside right below it. So definition of midpoint. So you always have like statements and justifications. So statements is like, hey, these two things are congruent. Those are statements. Conclusions are the reasons why we could say that. And so you have to have always some sort of like theorem or definition. I will tell you guys, you're going to get to a point where like you might like blank out on the test or the quiz, where you're going to be like, oh man, I forgot its name. Like, I know what it is, but I forgot its name. If you can like recite it ish, I'm not saying like word for word, but if you can kind of tell me why you think you can do what you can do, like, I'm okay giving you credit for that. So you don't have to actually memorize the names. Really what I'm looking for is that you guys can apply things. Okay, so if J to P is equal to P to K, then that means that X is equal to 5X minus 8. And that is by substitution. And then what you notice is that looks kind of weird, but basically what I did is I subtracted 5X from both sides of the equation. I combined like terms because I had to combine my or my positive X and my negative 5X. And then if I get X is equal to 2, which is what I was trying to prove, this was because I divided both sides by negative 4. So this is the division property of equality. Okay, so that's my little flow chart proof. And then we have a bunch of like theorems that I just used. They're pretty like self-explanatory. Reflexive is so important. So like something is equal to itself or congruent to itself. We use reflexive quite a bit actually. And then distributive property. Okay, so now if I look at this, I'm going to fill in the blanks again. So I'm going to tell you, and I forgot to write, like, this should be statements and reasons. Okay, so I'm going to say that given is xy is equal to 42. So now I can say that xz plus zy is equal to the entire thing. This is segment, because I added little segments together to make one big segment. So this is segment, oh my gosh, addition postulate. And then I went ahead and I substituted my value, so this is substitution. And then I distributed my three-able terms, so this is distributive property. Okay, it's been a long day, so I apologize. My handwriting is terrible right now. And then looks like I combine like terms. And then I subtracted 12 from both sides, so this is subtraction property. Of equality. And then to get n is equal to 5, I divide it, so division property of equality. Okay, so that gives us, proving things, some of the things are true. Now, there is a check for understanding here. So you can go ahead and pause the video for a second and see if you can try to do the check for understanding here. And then unpause the video at some point and then see if you got the right answer. So go ahead, pause the video for a second. When you unpause, you'll see me go over the answers. All right, so we're back. And when we look at, I'm looking at definition of a midpoint. So what am I saying? I'm going to say that AB is equal to BC. And then I'm going to say DC is equal to CE. And then I was given AB is equal to CE, so that's fine. So we could say, BC is then equal to CE. Because I can take this and I can plug it in here. So this is by substitution. Because I'm plugging in something. And then again, I can use DC is equal to CE by plugging in here. And so that's also substitution. Okay, another little flow chart guy. So now I'm going to go ahead and substitute. So 4x minus 6 is equal to 22. And then I'm probably going to want to add, so 4x is equal to adding 6 to both sides, so that gives me 28. So this would be addition property. And then I'm going to go ahead and divide by 4, so I get x is equal to 7. Okay, so hopefully you got the same thing that I did. And that is it for this lesson.